That's a truck drive 120 and has stuck up in this position. So the guy said is popping out some fuses inside here. So I will have a look on them and see what's happening, and then we're gonna try to test it. So I have an impression that it is working fine if it's working on the booms and working elevated, but as soon as you try to drive steer, then it would pop the fuse or something. So here under the canopy, I think he's talking about that thermal trip over there, and like you can see, it's popped. So that's the circuit breaker is popping out. I wonder why, but I'm not sure which one is that, but I think that's a 35 amp. So we will try to test it and see what's happening. I'll start the diesel engine now. Go and preheat. Not starting. So what I found now, every time I'm going to start the engine, that trip pops out. So I pushed it back in. It's pushed back in. I'm gonna switch the engine on. I have no engine start. And I think that thing popped out again. So let's see. Yeah, you can see it has popped out again. I wonder what is popping it out. So I can feel some burning smell. I think I'm gonna try to measure some currents. See where the current is going to, and then we go from there. So the first, I'm gonna put the clamp meter on the battery positive, and then we're gonna see how much current is going out. I'm gonna enable that back on, and then let's try to switch it on and see what's gonna happen. Now what you need at most is not working. Okay, so we're measuring current. So enable. So you got 9 amps. Oh, not 9, sorry, 0.9 amps. Start engine. 1 amp glow. It's not working as well. Okay, so we have no glow, no start, no current coming out. And the trip has popped again. I wonder why. I think I have to look on the drawing to see what that trip is actually feeding. Maybe that way it's gonna be easier than opening this canopy. Oh, look, I found something interesting. So I moved the clamp meter from battery onto this pull cable. That's our pull to the solenoid. And look what's gonna happen now. So I'm measuring the current. I already seen that, but I will show you as well. So this is off, everything's off. And that's my current reading here. Okay, so I'm gonna push the trip in. 3, 2, 1 is in. Look, it's drawing 70 amps, 90 amps, 85, 80, and it popped out. So it's kind of a good thing that it's a good thing that I identify what the problem is, but I still need to open this canopy and get to that box. I think there's something wrong with the supplies to that solenoid. So I've got the canopy off. Whew, that was not an easy task, but it is off. So I'm gonna get into that box, and then we're gonna see where the feed is coming from to that solenoid. So we are here in the box. So actually, yes, this is a 35 amp trip, not a 10. And some of those relays is gonna be for the solenoid. Let's see if there is any identifications on it. It will be a hold or pull. Okay, nothing there. So still, yeah, let me get the drawing and we're gonna know for sure which one is it. Just looking on the schematic here, and so that's a capacitor. I have seen it in the box. So it's a hold relay, and this is the pull relay number 10. So I think it's something wrong with that relay. Is it either way permanently energized or is welded on, because it's a contact, not a contact, solenoid is pulling 90 amps, so it's way too much. So I think it's possibly the problem with the solenoid, and that may actually welded the relay on. And here we are the box. So that's a capacitor, that's a hold relay, and that's relay 10. So the feed comes into the relay 10 and the control wires here. So I will remove this wire. I think this wire 87, it goes into solenoid. Yeah, you can see 87 goes to the throttle solenoid pull. So I think we need to inspect that relay. Then we need to have no power on the relays. We don't have it because that's tripped. So I'm gonna try to remove the inner side of the relay to have a closer look, do some visual inspection on it, and then maybe we can see from there what else we need to do. So pull the relay out of it. Let's have a look together. Okay, yeah. I wonder if that relay is actually always energized. Let's try maybe and figure it out. So we got a power on it now. Let's put the power on. Okay, nothing happens. I think as I move the relay, it's possibly dropped out. So let's try to start the engine now. Switch engine, throw glow, start. Engine is running. Set the high revs. Gonna press enable button. Okay, it did cut out. So it revved up. So it's gone into high revs. Let me switch it off. So it's gone into high revs. And it tripped the fuse again. So actually I think what is happening is that the current draw is extremely high from that solenoid, so it's damaging that relay. I mean, you can see that's flattened out. So I think to start with, I will replace the relay and I will replace the throttle solenoid as well. I'm gonna do a cheat way. So this is a new relay. I will just replace internals, leaving the case in there, so I don't have to unbolt it, and it's easier to do that way. Saves a bit of time, but that's how the new relay looks like. And this is the relay we have. So relay done. So we're gonna go on to solenoid. So that's my old solenoid and a new one. I want to do some resistance check on it, so for comparison, to see what's the difference between new and old. And we're gonna put a meter in there. So common ground, it's gonna be my black probe. So hold coil on an old solenoid. Wait. We're gonna have to find a way how to do it. I'm sure the crock clips would help here. But we're doing it. Okay, so hold coil on old solenoid, 12 ohms. let's measure the pull. And the pull is reading 0.4 ohms. So my multimeter, if I touch the probes together, so that's reading 0.32. So I think there is no much resistance in that coil, but I would expect that to be low anyway. So now on a new solenoid, we do a hold. Let me do it this way. So hold coil on the new one is 16 ohms. Do it one more time. Yeah, so that's 16 ohms, right? And the pull, try to do somehow. So the pull is reading 0.6 ohms. Slightly higher, but it's expected to be low resistance because it's the powerful coil to pull that solenoid in. So that pull coil is actually going to move the solenoid. So it needs a lot of power to move it. And a hold is just going to hold it in that position and keeps it there. So the current is lower. So this one is definitely having lower resistance, and we saw it together is drawing 90 amps, which is, I think, is way too much. So we're gonna see how many amps it goes on this coil. So many times I've been asked about this diode here, if it's needed, and it's just a flyback diode for the coil. And I'm just gonna test the diode now, just make sure it's not shorting out, because if that diode is shorted, it would result in a high current draw. So diode is actually in this bit here, and I think you can possibly see here by its shape, it's possibly right there. And the way to test it, we're gonna go into diode mode on the multimeter, so which I am already. And we're looking for a diode drop between this red wire, yeah, so that's your ground, and the red wire. So if we go this way, and let me just put a probe in it this way. So in black on negative, red on red, and we have open circuit, so there is no short circuit, which is good. And now if you swap them around, so we're gonna go red on negative and then black onto red one, we should have a diode drop, and we do, yeah, 0.547. So we know that diode is good. So I'm just gonna continue assemble solenoid, and then we're gonna retest it. So that's a new solenoid assembled. All the wiring, hold goes to hold, pull to pull. So we're gonna put the clamp meter again on a pull coil, and we're gonna see what sort of current we're gonna have now. I'm gonna push this back in, so really assembled here, all good. I'm gonna switch on the engine. So engine is running. Set it high revs. I'm gonna press enable button, and we're gonna see the current. So 3, 2, 1. One more time. So current goes up to 30 amps, and it drops out after a second or two. So 3, 2, 1. The 30 amps drops out, and the whole coil is taking over and holding the solenoid in position. So all seems to be good now. So done all the function test, and it's all working fine. So really new solenoid, as good as new.